the deepest we've ever seen into the sun. For most of human history, the sun was both familiar and untouchable. It was there every morning, rising over mountains, oceans, cities, and deserts. It gave warmth, marked the season, helped crops grow, and became one of the first things human beings ever looked at with wonder. But for all that time, we're only seeing the outside of the story. To the naked eye, the sun looks simple, a bright golden circle in the sky, too bright to stare at, too far away to reach, and too constant to question. But once scientists began looking at it with the right instruments, that calm golden disk disappeared. In its place was something far more violent. The sun is not peaceful. It is not still. It's a living storm of plasma, magnetism, radiation, and explosions large enough to swallow entire planets. And with modern space observatories, especially NASA's Solar Dynamics Observatory, we've been able to see the sun in ways no human eye ever could. What we found was not just beautiful, it was terrifying. The sun we see from Earth. From the ground, the sun feels predictable. It rises, sets, and returns again the next day. That routine makes it easy to forget what we are actually looking at. The sun is a star, and stars are not gentle objects. They are giant engines powered by nuclear fusion, constantly turning matter into energy. The visible surface of the sun is called the photosphere. This is the part our eye recognizes as sunlight. Sometimes, if scientists look at it through special filters, they can see sunspots. These darker areas may look small from Earth, but many of them are larger than our entire planet. Sunspots are not just marks on the surface, they are signs of intense magnetic activity. They show where the sun's magnetic field has been twisted, concentrated, and unstable. And when that magnetic energy builds up too much, the sun can't release it suddenly. That's when the star we depend on can become dangerous, looking beyond visible light. The problem with studying the sun from Earth is that human eyes are limited. We only see a small part of the light the sun produces. There's much more happening in wavelengths we cannot see, like ultraviolet and extreme ultraviolet light. These invisible wavelengths reveal parts of the sun that are hidden from ordinary vision. But Earth's atmosphere blocks much of that light before it reaches the ground. That's good for us because some of that radiation would be harmful. But for scientists, it means the deepest and most active layers of the sun atmosphere are partly hidden. So we had to go above the atmosphere. That's where space telescopes change everything. NASA's Solar Dynamics Observatory, launched in 2010, was built to stare at the sun constantly. It does not just take one kind of image, it looks at the sun at different wavelengths, and each one reveals a different temperature, layer, or structure. In one wavelength, the sun may look calm and golden. In another, it looks like a glowing red storm. In another, it becomes blue, green, or purple, filled with loops, scars, dark holes, and violent eruptions. These colors are not the way the human eye would naturally see the sun. They are scientific translations, turning invisible light into images we can understand. And once we saw those images, the sun stopped looking familiar. The sun's hidden atmosphere. Above the surface of the sun is a thin layer called the chromosphere. During a total solar eclipse, it can sometimes appear as a reddish rim around the edge of the sun. Above that is the transition region, where temperatures rise sharply. Then comes the corona, the outer atmosphere of the sun, stretching millions of kilometers into space. The strange thing is that the corona is much hotter than the surface beneath it. That sounds backwards. Normally, the farther you move away from a heat source, the cooler things get. But the sun does not behave that simply. Its magnetic field is constantly moving, snapping, reconnecting, releasing energy into the atmosphere. When we look at the sun in ultraviolet light, we can see this happening. Giant loops of plasma rise from the surface and follow invisible magnetic lines. Some loops stay attached to the sun, others break apart. Huge dark regions called coronal holes open up, allowing solar wind to stream into space. It is beautiful to watch, but it's not just a light show. These are the signs of a star that is constantly changing. When the sun erupts. Sometimes the sun releases energy all at once. A solar flare can explode from active region near a sunspot. sending radiation across space at incredible speed. These flares can affect radio communication on Earth, especially when they are strong enough. Then there are coronal mass ejections. These are massive clouds of charged particles thrown out from the sun. If one of them is aimed toward Earth, it can slam into our magnetic field and create a geomagnetic storm. Sometimes the result is beautiful. Auroras glow across the sky, turning the poles green, red, and purple. But the same event that creates those lights can also disturb satellites, affect GPS, damage communication systems, and put stress on power grids. This is why studying the sun is not just about curiosity, it's about warning. The sun may be 93 million miles away, but when it erupts in our direction, Earth can feel it. A solar storm does not need to touch the ground to affect modern life. It only has to disturb the technology we now depend on. How deep can we really see? When we say this is the deepest we've ever seen into the sun, it does not mean we have looked directly into its core. The core is still hidden far beneath layers of plasma. That is where nuclear fusion happens, where hydrogen is turned into helium, and where the energy that keeps Earth alive is born. But that energy does not escape immediately. Light created in the core can take an incredibly long time to work its way outward, bouncing through dense layers before finally reaching the surface and escaping into space. We cannot send a camera into the sun. We cannot drill into it. No spacecraft can survive that environment for long. But scientists have found other ways to study what is happening beneath the surface. The sun vibrates. Its surface moves with waves caused by activity inside the star. By studying those waves, scientists can learn about the hidden layers below, almost like using sound to understand what is inside something we cannot open. Why this view matters. The deeper we look into the sun, the more we realize that Earth is not separate from it. We live inside the sun's influence. Its light warms us, its gravity holds the solar system together, and its charged particles constantly flow past our planet. Most of the time, Earth's magnetic field protects us. It acts like a shield, guiding dangerous particles away. But that shield is not perfect. A strong solar storm can still cause problems, especially for satellites, astronauts, aviation routes, power systems, and communication networks. This is why NASA and other space agencies watch the sun so closely. Every image, every flare, every shift in the magnetic field helps scientists understand what might be coming next. The sun is not just something in the sky, it's a part of our environment. Its storms are part of our weather, even if that weather begins in space. For thousands of years, human beings looked at the sun and saw a symbol of life, power, and time. But now, for the first time, we are seeing it as it truly is. Not just a bright disk above, but a violent, layered, restless star. The deeper we look, the stranger it becomes. We see loops of burning plasma larger than Earth. We see dark holes opening in its atmosphere. We see eruptions powerful enough to cross space and shake the invisible shield around our planet. And yet, even with all this technology, the sun still keeps its deepest secrets. We can study its surface, its atmosphere, its storms, and even the waves moving beneath its outer layer. But the heart of the sun remains hidden. Maybe that is what makes it so fascinating. The object we see every day is still one of the most mysterious places in our solar system. It's close enough to shape every moment of life on Earth, but powerful enough to remain unreachable. For now, this is the deepest we've ever seen into the sun, but it's not the end of the story. It's only the beginning of a closer look at the star that gives us life, and could one day remind us just how fragile that life really is.